Hello everyone. Today we are going to see the last topic of module 2 dynamic programming. The last topic is traveling salesman problem. Now till now we have seen the shortest distance problems like this one. We have seen the single, so when there is a single source and multiple destinations, we use for the Dijkstra's algorithm or the Bellman-Ford algorithm. When the age weights are negative, we go for Bellman-Ford algorithm, otherwise we go for Dijkstra's. In this case, we have a single source and remaining all the vertices are our destinations. Now the second case was when there is a single source and a single destination vertex, we go for multi-stage graph. And third is we have seen all pair shortest path, that is we have found out the shortest distance between all the pair of vertices. For that we have used the Floyd-Warshall algorithm. Now today we are going to see another concept, that is traveling salesperson problem. Now we are with a salesman who has to traverse all the cities exactly once and return back to the source vertex. That is, he will start his tour from a single vertex, traverse all the vertices and return back to the source vertex, and this distance whatever he covers, that should be our minimum distance. So again, for this we are going to use a formula. This is a formula. Now every time we have to consider that when he start his tour from a vertex, we have to consider the intermediate vertices, whether there is 1, 2 or 3 vertices. We'll understand this formula as we are going to see the example to implement. So to clear with the concept, we are going to consider one example which was asked December 14 for 10 marks. Now given is a graph which consists of 4 vertices. Now here one is the start vertex, that is the salesman starts from his tour from the salesman starts his tour from vertex 1 and he has to traverse all these 3 cities and return back to the vertex 1. We have to find out the path which will give us the minimum distance. So the very first step is we'll write the distance matrix from the given graph. Distance matrix is nothing but the adjacency matrix for the given graph. You all know how to write an adjacency matrix, so I have written the adjacency matrix for this given graph. Now we have already seen this is the formula which we are going to use. How to use this formula, that we are going to see in the subsequent steps. Now that tour is going to start with vertex 1. Now we are going to consider, this is the start vertex, so we are going to consider 3 different steps. In the first step, we'll assume that we suppose the vertex is 2, so the tour, the salesman is at vertex 2 and he has to go back to vertex 1 directly. That is, there is no intermediate vertex between 1 and 2. That is, there is a path from 1 and 2 or 2 to 1 and there is no intermediate vertex in between that. So that will be our first step, when the intermediate vertices are null, that is when the distances are directly given. So I'm going to write here cost, the starting vertex I'll write 2. Now what is this? We have formula cost I comma v, where v is the set of vertices, intermediate vertices. Now in this case I am writing 2 because our 2 starts with 1, so the remaining vertices are 2, 3 and 4. So we are assuming that the start vertex is 1. So once the tour starts from 1, if the salesman go to 2, he has to come back from 2 to 1. So we are going to consider the path from 2 to 1. So our tour starts from 2, will not start from 1, that will be our last step. So here we are assuming that the salesperson is at vertex 2 and he has to come back to vertex 1 and there is no vertex in between. That's why that is the first step. There is the set of vertices is null, that is cost 2 to 1. The distance between 2 to 1 and the intermediate vertex is null. So this is straightforward, distance of 2 comma 1. So from the distance matrix 2 and 1, the distance is 5, so I'll write here 5. Next, again now I'll consider the vertex 3, intermediate vertex null. Now we are calculating the distance from 3 to 1 when there is no intermediate vertex. So again this is straightforward, distance of 3, 1. So from matrix 3 to 1 is 6. Third case, distance of 4 1. So from matrix 4 1 is 8. That means this is our first step. First step means what? When there are no intermediate vertices, that is, we are finding out the distances between 2 1, 3 1, 4 1 when there is no intermediate vertex. So what will be our step 2? Step 2 will be when the intermediate vertex is 1. There is one single vertex between the 2 1, 3 1 and 4 1. So here the first case I'll write cost 2. Now again we have to find out the distance from 2 to 1 as we have done here. We have found out the distance from 2 to 1 when the intermediate vertex is null. Now again we are finding out here from 2 to 1 when the intermediate vertex is a single vertex. Now except 2 and 1, there are remaining vertices are 3 and 4. So the intermediate vertex can be 3 or can be 4. So first we'll consider 3. That is 2, 3 and 1 equals to. Now we are going to use this formula. This is I and the set of vertices. So here also we have done this. This is I, this is the set of vertices, and 1 we have written as we have to return back to 1. So this is I, this is V. So here I am writing mean. Now the formula says distance of ij. Now this is I and j belongs to this set of vertices. Now in this case this set consists of a single vertex. So this is j, this is I, this is j. So distance of ij. This is I, this is j. So mean of distance of 2 3 plus cost of, the formula says this is what, j. So here this is j, comma, and here this is v minus j. Now v is what? This is the v, and subtract j from it. J is 3 itself. So if we subtract 3 from this set 3, we get null and the remaining 1. See what we have written? We have implemented the formula. We have, see what we are considering, the intermediate, when the intermediate vertex is 1, that is we are finding out the distance between 2 and 1 when the intermediate vertex is 3. So here this is I and this is j. So the formula says minimum of distance of ij. So this is I, this is j. So 2 3 plus cost of this parameter is j, and this is what, v minus j. Our v consists of 3 and we are subtracting 3 from it, so we get null and 1. So here this is a single value, so we do no need to write here mean. So distance of 2 3 from the distance matrix we get 9 plus this cost of 3 null 1 we have calculated from the previous step, that it is 6. So 9 plus 6 we get 15. Okay, now we'll consider the second case, cost of 2 when the intermediate vertex is 4. Here when the intermediate vertex is 3, now we are considering the intermediate vertex is 4. So minimum distance of, this is I, this is j. So 2 4 plus cost of, now this is j, comma, this is 4 minus 4, so we get null 1. So equals to distance of 2 4 from the distance matrix is 10 plus this we have calculated as 8, so we get 18. This is our first case, that is we are finding out the path from 2 to 1. Now the second case will be finding out path from 3 to 1. So when the intermediate vertex can be 2, can be 4. We are finding out the path from 3 to 1. So intermediate vertex can be 2, or the second case, the intermediate vertex can be 4. Finding out path from 3 to 1. Intermediate vertex can be 2. Here intermediate vertex can be 4. So here we get mean distance of 3 2 plus cost of 2 null 1. So this we get as 13 plus 5 equals to 18. So again this formula, mean distance of 3 4 plus cost of 4 null 1. So this we get as 12 plus, what is that value, 8. So we get as 20. So we have considered path from 2 to 1, path from 3 to 1. Now the third case is path from 4 to 1. So when we are considering 4, the intermediate vertex can be 2 or it can be 3. When we are finding the path from 4 to 1, the intermediate vertex can be 2, can be 3. So we'll solve one by one. This will be distance of 4 2 plus cost of 2 null 1. So this is equal to 8 plus 5, 13. Now this again distance of 4 3 plus cost of 3 null 1. So 4 3 is 9 plus 3 null 1 is 6. So we get here 15. So we have done with the step 2, wherein we have considered the intermediate vertex is 1. Now we'll go to the step 3, where the intermediate vertices are 2. Okay. Intermediate vertices are 2. That means we are going to again find the path from the vertex 2 to 1. So first step, I'm writing cost of 2 to 1 when the now intermediate vertices are 2, so that can be 3 and 4. Only one case we are finding out the path from 2 to 1, so the intermediate vertices are 2 now, here 2, so that are 3 and 4. Now how to use the formula? Okay, now here mean. Now we get two cases. Here this is a set of vertices where you have two values of j. So this is one value of j, this is other value of j. So first we'll consider the j value as 3. This is I, this is j. So distance of I is to j is 3. I and j. So distance of 2 3 plus cost of j. What is j? J is 3 comma. What is here? V minus j. This is our v. J is 3. So from this entire set subtract 3. So you get remaining vertex is 4. So here I'll write 4 and 1 as it is. Similarly, now I'll consider j as 4. The second case, I is 2, j is 4 plus cost of j is 4, and this is our set. So subtract j from it. J is 4. So remaining vertex is 3. So we get here mean. Now this is 9, and this we have calculated in the previous step, 3 4 1. So here 3 4 1 we have calculated as 20. Distance of 2 4 is 10 plus this we have calculated 4 3 1 as 15. So we get here mean 29 25. So we get here value 25. Okay, now second step, we are going to find out the path from 3 to 1. 3 to 1 when the intermediate vertices will be 2 and 4. This is the path, or this is the cost for the path from 2 to 1 when the intermediate vertices are 3 and 4. Now we are going to find out the path from 3 to 1. So intermediate vertices can be 2 and 4. So again implement the formula. Distance of I is 3. Now j first we'll consider as 2 plus cost of j is 2 comma v minus j. This is v, j is 2, so cut 2, remaining is 4 comma 1. Second case, I is 3, j is now 4 plus cost of j is 4 and v minus j, so remaining is 2. So here we get 3 2 is nothing but 13 plus this is 241 we have calculated in the previous step here, that is 18, and distance of 3 4 is 12 and this is 13. So we get here mean 31 and 25, so the minimum value is 25. Now the third case, minimum path from 4 when the intermediate vertices will be now 2 3 1. We have considered 2 to 1 path, 3 to 1 path. Now the last case is 4 to 1, so intermediate vertices will be 2 and 3. So equals to mean, again two cases, distance of 4 2 plus cost of j is 2 comma, now this is v minus j, so remaining is 3 1. Second case 4, now j is 3 plus cost of j is 3, remaining vertex is 2 and 1. So we get here mean 8 plus 15 and here 9 plus 18. So mean here 23 and 27, so we get the minimum value as 23. So this is the step 3 when the intermediate vertices are 2. Now we'll go to the last step, step 4, when the intermediate vertices are 3. Now we have total 4 vertices, and when the intermediate vertices are 3, that means we are going to find the now shortest distance starting from vertex 1. From vertex 1 the intermediate vertices will be 2 3 4, return to 1. This is our final answer. Start the tour from 1, the intermediate number of vertices are 3 and destination is also 1. Now implement the formula mean. Now we have 3 values for j, so you'll have 3 different cases. The first case is when j equals to 2, so distance of I is 1 and j is 2, so 1 2 plus cost of j is 2 comma, now this is v minus j, so subtract j from this, we get here 3 4 and this is 1 as it is. Second case when j is equal to 3, cost of 3, now subtract 3 from this, we get here 2 4 1. Third case when j is equal to 4, cost of 4, subtract 4 from this set of vertex, we get here. So we find out the values here. This is 10 plus 25. The second case is 15 plus 25 and 20 plus 23. So we get here mean, this is 35, 40 and 43, so this is 35. So this is the final answer, that is minimum distance, shortest distance required to cover the tour starting from 1 returning to back to 1 is this. Now what is the path? This is the distance we have calculated. Now to find out the shortest path, we have to traverse back. Now this is 35 we have got because of this is because of this, now this is because of this first statement. So this first statement, that means this distance 1 2, so I'll write here vertex 1 2. This shortest distance 35 was because of distance 1 2, distance of 1 2 is 10. Okay, now we are at here. Now what is this? Cost of 2 3 4 1. So we'll go one step behind and find out this cost of 2 3 4 1. So go one step behind and go to cost of 2 3 4 1. Yes, now here this is 25. 25 was because of this, this is because of this, this is because of this. That means what? This distance is 2 4. So 2 4, so from 2 I'll go to 4. 2 to 4, the distance is 10. So we are here, 2 to 4 we have considered. Now consider this, cost of 4 3 1. Go one step behind and go to cost of 4 3 1. Yes, this is the shortest distance. This was because of this. Now this is because of this, that is distance of 4 3. So after 4 I'll get here 3. Okay, 4 to 3, the distance is 9. Okay, now we are here, we have considered this. Now what is this? Cost of 3 null 1. Go one step behind here, cost of 3 null 1, the distance is 3 1. That means after 3 I'll write here 1, 3 2 1, 3 to 1, the distance is 6. Hence this is our shortest path with distance. If you add this, you will get 35. So this is our shortest path which the salesman has to traverse. Thank you.